Good morning, students. I'm going to give this a go. So we're going to show you a few examples on factoring quadratics. And here is a very simple one. If we had these two binomials of x plus 5 and x plus 4, we would know exactly what to do to turn that into a quadratic. We would take this x and distribute it to that x, and then by distributing we know we're multiplying x times x, that's x squared, right? And then we would take this x and distribute it to the positive 4 here, and we'd have x times positive 4 is positive 4x. Now we're going to go on and distribute the 5. So the 5 times the x would be a positive 5x. And then finally, we would distribute the 5 to the 4. 5 times 4 is positive 20. At this point, we could then combine like terms, right? Grabbing another pen here. And so this x squared is in the like term with any of the others, so that one can just come on down. But this positive 4x and positive 5x, those can be combined. So 4x and 5x together make positive 9x, and then this positive 20. So what we have here is these two binomials, this x plus 5 times this x plus 4 is equal to this quadratic, x squared plus 9x plus 20. So what we need to do now with factoring is I'm going to say, all right, we have this quadratic. We have x squared plus 9x plus 20. Can we factor that into two binomials? All right, so we can. We already know what the answer is. It's going to be x plus 5 and x plus 4, and you can write those down. But if we didn't have the answer right here, and we just had this, let's think about each of these terms in the quadratic and what they were originally here. So what I mean by that is this x squared. This x squared was the answer to something here times something here. What here times what here make x squared? Oh, easy. I'm going to go back to the same colors. X and x. X times x is x squared. Now I'm going to suggest that we don't worry about this 9x for a minute, but we're going to go to the ending term, this positive 20. Looking back up here, it was the ending one here and the ending one here. The last part of this binomial and the last part of that binomial multiplied together. Positive 5 times positive 4 made 20. So this 20 here is a positive 5 times the positive 4. So now you might be wondering, well, where does that 9x come from? That 9x was the combination of these other two terms, the x times 4 and the 5 times x. So what we have here, get the right color, this one, x times 4 would be 4x. And in the center here, the 5 times x would be 5x, and they're both positive, and so look what happens when you combine them. There they are. Okay, so that's how you can tell that you were correct. You worry about the first term, then we jump to the last term, and then we double check to see if when those others were combined, they made that center term of 9x. So let's try another one. Let's look at this one. X squared plus 10x plus 9. Let's see if we can come up with the two binomials. Equals. So notice that I started with the blanks. And once again, this x squared is first, and so I'm thinking what here and what here multiplies to make this. X times x. Now I'm going to jump to that last term. It's a positive 9. What times what here times here makes positive 9? So in your head you might go, oh, it's 3 and 3. Well, if we try 3 and 3, we're not going to get that middle term. Watch. So I'm going to say, well, I think it's 3 and 3. I'm going to use pencil because I already know I'm going to have to erase it. I'm double checking that my video is still working. It looks like we're doing okay. So now let's double check it. The first one's here, x times x. We already know that's correct, x squared. Now, I know that 3 times 3 is correct. That's that positive 9 that I need. But now let's deal with this one. That would be x times 3, 3x. And then this one, 3 times x, 3x. If I'm combining these, 3x and 3x, I get 6x, and that doesn't match. So what we have to do then is go, well, shoot, I know that the x times x is right, that's x squared, and I know 3 times 3 is right, that's 9, but I'm trying to get 10x here. So your question is there anything else that multiplies together besides 3 times 3 to get 9? There is. I'm sure there's somebody out there who already knows what I should be writing. What else multiplies to make 9 besides 3 times 3? A positive 9 and a positive 1. Doesn't that indeed also multiply to make 9? So I have x times x, x squared. And then I have 9 times 9, positive 9. But let's look at this outside and this inside. So here I have 1x, and here I have 9x. Combine those like terms, positive 10x. We did it. All right. So that's when everything's positive. What we're going to go on to next for our next example is one where there's a negative sign at the end. So let's take this one, x squared minus 10, no, I said we're going to start with a plus here, plus 10x, now I'm thinking because I messed up, and then I'm going to do this one, minus, hold on, I'm concentrating here, that will work. X squared plus 10x minus 24. So I'm trying to factor this, meaning I want to know what's in the binomials that if multiplied out made x squared plus 10x minus 24. Did I get that right? Yeah, I'm double checking. So remember, just like before, that this first one here, this x squared, would be x times x. Now take a look at this, minus 24. These other examples we had positives at the end, but this one's a negative. So when you have a negative at an end, that's going to affect something in here. That means I'm going to have to take some negative number times some positive number to get a negative 24 at the end. So I can start by just putting in those signs. That's what I know so far. Okay, so now 24 is an interesting one because it has so many different factors. It could be 4 and 6. It could be 6 and 4. What else multiplies to make 24? 3 and 8? Or 8 and 3? What else? I think we better make a list. So what I do is over off to the side here, I actually do that. I make a listing of pairs of what multiply to make 24. So, and I try to think of some sort of a sequence so I don't miss anything. So I'm thinking of the smallest possible factor, which would be 1. 1 times what makes 24? 1 and 24. Okay, then let's try 2. 2 times what makes 24? 2 and 12. That's a pair, okay, that multiplies to make 24. This is also a pair. I'm going to keep going here. 3. 3 times what makes 24? Well, 3 times 8. And then we talked about 4 and 6 because those multiply to make 24. And do I have any others? I have all of these in reverse. I could have 24 and 1, 12 and 2, 8 and 3, and 6 and 4. So you can just kind of keep that in mind, that you could also have all of these numbers in switched. So now remember that this isn't just 24, it's a negative 24. So when we're looking here to figure out how I should place these, I have to think that one of these is negative and one is positive. Negative 1 and positive 24? Or maybe positive 1 and negative 24? Or negative 2 and 12? Or could it be 2 and negative 12, etc.? So notice that we have lots of combinations here. Okay, why is that important? Why can you just not write any of those? Because you know that they're all going to multiply to make a negative 24 because I have a negative sign and a positive. It's this term here. Okay, looking back at these to make the 9x and to make the 10x here, we added those together. So for this one, I'm looking at adding two numbers together that once added make positive 10. Okay, so remember also that's one's negative and one's positive. So if I had a negative 1 and a positive 24 and I added those together, I would get 23. If I had a positive 1 and a negative 24, I would get negative 23. Those aren't going to work. I want positive 10. Let's look at these. Let's think this is the negative 2 and this is a positive 12. So if I have a negative 2 and a positive 12 and I add them together, what do I get? 10. Okay, so negative 2 and positive 12 will make this term here once I factor it out, and I'm going to double check that in a moment. Let's just move on here. What if this was a negative 3 and this was a positive 8? Negative 3 plus 8, does that make positive 10? No, it doesn't. It makes positive 5. Or negative 5 if we switched them to a positive 3 and a negative 8. And same here, it does not make 10. A negative 4 plus 6 would make positive 2, or a 4 and a negative 6, that would make negative 2. Okay, so I think we're pretty good here, but this is how you double check. Now you're going to distribute it. X times x, x squared. X times 12, positive 12x. And now distribute the negative 2. Negative 2 times x, negative 2x. And then negative 2 times 12, negative 24. We knew it would have to be that. Okay, so now bring that one down. Combine like terms. Positive 10x minus 24. We did it.